Good morning at Pre-Calculus. Today we get to start Chapter 10, and we're going to be looking at topics in analytic geometry. Again, if you take the time and preview that chapter, there are 9 sections. I'll probably have 2 tests in this chapter. I'm not certain if I'm going to do the test after 10.4 or after 10.5, and then do 10.6 to 10.9 as a second part of the chapter. So I haven't decided yet, but just count on 2 tests in this chapter. Again, this section deals with nothing but the topics dealing with analytic geometry, specifically conics. Again, lines, parabolas, ellipses, hyperbolas, circles. We're also going to learn something, quite a few new things in here. Rotation of a conic, this is going to be new to you guys. Also looking into parametric equations, polar coordinates. That stuff is really interesting. I think you'll like it. All right, so let's look at today. Let's look at section 10-1. I'm going to do this in 2 parts. So here's part 1, section 10-1. The big question we want to ask us is, how do you find the angle of inclination of a line and also the distance between a point and a line? Now you're probably saying, yeah, this is going to be relatively easy. Yes, it can be, but remember now we're going a little bit past algebra concepts, and we're getting into more into the use of trigonometry and how to find an angle of inclination of a line, and how do we use trig when we're dealing with the distance between a point and a line. So again, this is a little bit different. It's the same thing, it's just a little bit different using different formulas, okay? So that's what we're going to do with today. All right, the first thing we're going to do is we'll do it just like we've been doing all year. Again, Roman numeral 1 starts off with what the section's about, inclination of a line, which again deals with pages 728 and 729. Again, strongly encouraging you all to read your book, follow the examples, because that's the only way. Math is a active subject. It's not passive. You just can't read the book and say, "Yep, I got it." No, you got to actually get involved in it. 2 points to bring up on the inclination of a line. The first point gives us just some rules, so to speak. Every non-horizontal line, that means it's a line that's not like y equals 0. We can't do that, okay? Every non-horizontal line must meet the x-axis, and we will call the angle theta formed by the line and the x-axis between 0 and pi, which in this case, if you remember correctly, that's between 0 and 180 degrees, the inclination of a line. So here's what this is basically talking about. I have here, which I didn't draw nicely, here is our line. And I have expressed it in 2 ways, slope-intercept form and standard form. So again, your line is going to have, it will either be in slope-intercept form or in standard form. What we are trying to do is we're trying to find that angle between the x-axis, that's what this first line is, and we'll call this angle theta. And it's going to be that theta is going to be between 0 and pi. So our theta here is going to be, from 0 degrees all the way up to 180 degrees. That's our theta. You guys with me so far? That's what we're talking about. We're trying to find this guy right here using trig. All right, now, point number 2 sets up how we go about and do this. If a non-vertical line has an inclination angle and a slope of m, which again, you guys are very, very familiar with slope. I have taken the time over here. Over here is your slope-intercept form. The coefficient of x is your slope. Again, to find the slope of the standard form, again, this was done before. I took the equation and I solved for y. And we will see from this, if your problem's in standard form, you're going to see that this negative a all over b becomes the slope of the standard form of equation. So if a non-vertical line has an inclination theta and a slope n, then we're using a little bit of understanding of slope. Remember, slope is rise over the run. Rate of change divided by the rate of change of the y value divided by the rate of change of the x value. And if you go back and think of trig, trig goes back to the idea of tangent. Now you're probably saying, where does that come from? Well, if you go back to tangent, tangent is the opposite side divided by the adjacent side. So if we were to look at this graph right here and we were to make a triangle, and if we want to find this theta, you got to watch me here, okay? Here's your line. If we want to make a triangle, okay, we can figure out what theta is. That's this line right here. And to do theta, we need the opposite side of this angle, which right here is this guy right here. That's your y value, divided by the adjacent side, which is your x value. So tangent really is y divided by x, okay? Now the tangent theta becomes your slope. Very important. Now the proof of this is on page 806. I'm not interested in that. So again, I showed you graphically what that looks like. So we know slope is the change in y values divided by the change of x. And we also know that tangent of theta is really the opposite side divided by the adjacent side. So that tells us these two informations. We can find this angle of inclination just by looking at the function, or by looking at the equation, okay? So down below I have two examples. Both of them are set up. I'll explain number one, and you guys can go and rewrite number two and look at that. So the first thing I did over here is we have the line of 2x plus y equals 5. If we take this equation and solve for y, we get negative 2x plus 5. Now again, give you guys an idea, it's going to look something like this. All right, so here is our slope is negative 2. Plugging that information again over here to find theta, once again, it's not that difficult. Theta will equal the inverse tangent of the opposite side, which is your y value, divided by your adjacent side, which is your x value. I didn't show that in this part, but you'll be able to see it. Now again, calculator time. So you go second tan. Again, in this case, we know our slope is negative 2. We don't have to do this part right here. You're more than welcome to. Is negative 2. Close that with parentheses and hit enter. Now again, this is our theta, but if you look at theta, it's written as a radian. So in order to find our theta, we have to go and convert a radian to degrees. So I'm going to let you guys handle that. All right. Again, over here to the right, this is the conversion of radians to the degrees. You take 180, multiply it times your radian. So in this case, 180 times negative 1.107, and you divide it by pi. Can't see pi. And you get negative 63. Now, don't stop there. Remember now, this has got to be between 0 and 180. See this? This is important. Your theta has got to be between 0 and pi, or between 0 and 180 degrees. This is negative 63.43 degrees. You can't have that. So you have to go and find out this, the complement to this. So again, you just take 180, subtract from that 63.43, and that's where you get 116 degrees. Now remember, if I was to go back and just remember, once again, if you look at this graph right here, and if we were to make our XY axis, okay, we know this has a y-intercept of 5. I'm just making this up. This is that graph. This is that theta. And it is definitely not negative 63 degrees, because if you go back, we know negative 63 degrees tells us this has got to be that negative 63 degrees, that's this angle right here. We can't do that in this situation. We have to go and make sure it's between 0 and 180. So that will take care of inclination of a line. You guys with me so far? All right. Like I said, I'm going to do this in two parts, so I'm going to do do this next part as the beginning of the first part. All right. So now the next one is how to find the angle between two lines, and that deals with page 729 to page 730. Once again, read those sections. Follow along with those examples. Like I said before, math is not a passive subject. You got to get involved in it. All right, now 2 points here, and we'll get into it. Two intersecting lines form two pairs of opposite angles, and the smaller angle is called the angle between the two lines. The rest is all mumbo jumbo. So if you look at it, if I have two lines here, I have the red line and the green line. We're trying to find the angle between the two lines. Just to give you guys an idea, we are trying to find this angle right here. All right. Bullet point number 2. If the two lines have slopes, well, again, this would be slope 1, and this green one would be slope 2. Then we can use, once again, our tangent rule, because remember now, inclination between a line deals with tangent. Now, what we had to do here in this case is we had to apply your add and subtract laws of trigonometry, which we had to use tangent. So basically what we're doing here is, if you go back and look at this angle right here, we can find this angle of inclination, and we can find the angle of this inclination, and the difference between those two angles is this guy right here. I'll do that again. We can find the angle of inclination here and the angle of inclination here. And if you find the difference between those two angles, that's this angle right here. That's what's going on right here. All right. Now this part right here comes from your sum and difference formulas from the tangent. Again, you'll have to go back to your HD&Cs or go back and preview the previous chapters on that. Down here, this right here, if you notice, it's in orange. That means an HD&C worthy. This right here will help you find the angle between two lines. You just need to know what the angle of one equation, you just need to know the slope of one equation and the slope of the other equation. So the example they have here, I'll just do one of these. Find the angle between the lines. I have 3x plus 2y equals 8 and 4x minus 5y equals 1. And we need to find the slope of this line and the slope of this line. Now, I brought this to your attention at the beginning of the section, and it goes over to this part. Again, you can find your slope of your line by taking your equations and solving for y. You're more than welcome to do that. But the problems we are given, they're already in this form right here. It's called the standard form, ax plus by equals c. Now if I take this part right here and we take it and solve for y, this right here will give you the slope of that line. All we need to know what a is, negate it. All we need to know what the value of b is, and divide that. That will give you your slope. That's just a little shortcut to help you guys out. So if you look at this problem right here, I know a is 3. I know b is 2. So you negate the a and divide it by 2. That tells me the slope of this first line is negative 3 over 2. That's going to be the green one, so to speak. The other one is, we know a is 4, b is negative 5. Again, negative a divided by b, so negative 4 divided by negative 5 becomes 4/5. That will be the slope of this one. Find this angle right here based upon this example. You just need to do the inverse tangent. Again, I didn't show it here. Again, you want to find this angle. So you have to go find divide both sides by the tangent. So this becomes the, I'll write it out for you guys. I have no problem with that. So theta equals the angle between these two lines will be the inverse tangent of the difference between the slopes of your two lines divided by 1 plus the product of your two slopes. And I have it in absolute value marks, so you have to take the absolute value of that. You know what absolute value is. Do your math, okay? So calculator, second tangent of 11.5 is, once again, this is going to be given to you in radians. You need to convert it from radians to degrees, and you'll see that this example right here, number 1, has an angle between the two lines of 85.03 degrees. So that is going to be the first part of section 10-1, how to find the angle of inclination and how to find the angle between two lines. All right, now once again, go back over, read your book, get involved in it, try those examples out. You know what your homework is. Feel free to give me a call if you need any more assistance. All right, love you guys. Catch you later.